Hi, I'm Juan Blanco. A bit about me. I've been involved in the blockchain since 2013. In Ethereum 2015, created Nethereum and also the VS Code Solidity extension. I have also been 24 years in .NET and more than T, so mainly I'm pretty old. So Nethereum, the vision of Nethereum is just to provide tools and frameworks so any .NET developer can create applications and integrate with Ethereum or even existing applications. The vision has always been bringing the love of Ethereum to .NET and vice versa. So what can you do with the .NET ecosystem and Ethereum? You can create desktop applications, you can create mobile, IoT, gaming, as we're going to see here, web WASM, as well as we can see here, line of business applications like SAP, and of course, cloud integration. And using Ethereum and .NET, you can have common logic that can work across. So what are the Ethereum features? So this is the same as any core client integration. You have the Ethereum node, JSON RPC, smart contract integration, your RLP, EVMs, signing, API encoding, indexing, L2 support, etc. We have all the standards and common protocols. So you have like CWE, Gnosis Safe, ENS, etc. Merkles, external wallets, if you don't want to create your wallet with Ethereum, like MetaMask, Wallet Connect, Azure Key Vault, etc. And tooling, Ethereum Playground, so you can actually test how Ethereum integrates code generators and many templates, like CWE, Blazor, Unity, etc. So, and what MUD brings to the plate? MUD brings new data models and dynamic schemas. It's something that we were really missing for create applications in gaming. And data indexing, something that we can actually rely on. And mainly the operability and be able to create new worlds and complex applications. So Ethereum brings the new packages. So we have Ethereum mod. So together, now we can create these great applications and games that we couldn't do before. So how does this work? So we've been doing this with Cafe Cosmos. So it has been fully tested there, and it works. So it's pretty cool. So what is Cafe Cosmos? So Cafe Cosmos is a game for management. You manage resources, you cook, you can do many things. And here we can see the Blazor version, which is a web application. As you can see, you got the tools, you can put fences there, you are cooking, etc. But obviously, this is a web application. So it looks much better as a Unity site. And so here we can see exactly the same view, but actually in Unity. So yeah, it looks much better than HTML version. So how does it work underneath? Here is got a small diagram we can see in the top. We got the Blazor version, the Unity version of the front end, all that connecting to a player service, which in itself it connects to the namespace in the .NET version, which is system service and table services that are MUD wrappers. Also includes a local state, just to keep the data locally and the logic, and all that integrated with obviously the Ethereum node, where they have the MUD smart contracts and obviously the custom systems and log processing and so on. On the right-hand side or left-hand side, you can see the storage processor. So you have all the data stored to the database. And in the other side, you can see how we can create a .NET integration test and obviously deploy it using .NET. So let's see how this works if we were adding some functionality to Cafe Cosmos. So Cafe Cosmos, wouldn't it be great, if you can have a crazy oven there? But sadly, I only have one simple oven, you know, but I don't have enough items to actually create craft my crazy oven. No, and I really, really fancy to having this crazy oven. So what if I could actually buy it instead of crafting and created a catalog, yeah? So let's start. How will it look like? So let's start with the smart contracts. So first of all, we'll create in our mod config, our table, so here we call a catalog item with a item ID, catalog ID, and a price, because we're gonna buy it. And then we will go and co-generate it. Because we are working on Windows, normally with Unity, you will have to use the Git bash or WSL2 because mod works better in a Unix environment. So once we co-generated our table, we can start working with it. So as you can see here, we got a new catalog system, and then we can access the data there for the catalog item. Then now we have the price, etc. And then this integrates with our other libraries, so we can get the token balance that we have, so we can do the purchases and validate it. So now we got our system created. What we're gonna do? So Nethereum now includes a new code generator. So this code generator is part of is integrated with the VS Code Solidity extension. So before Nethereum, you would have a simple code generator just to create your normal services. So but now has these mod extensions for table generations and mod extensions for systems. So once you created this, you just go to VS Code Solidity extension, right-click, and there you go. You can co-generate it. And then you've got these files. So here you have the catalog item record, your catalog table service, your catalog system service, your catalog system service mod extension. So let's have a look at this in detail. So first of all, let's look at the table record. A table record is exactly the same as we have seen before. It just maps it's just the representation of your catalog record. You got the catalog item key and the catalog item value, which includes the IDs, price, etc. Now we have the table service. The table service is what allows you to query directly the data from the smart contract, so we can get the records, set the records, or even use the logs. As you can see here, we can set the records. So for example, that will be our crazy oven. So we are gonna create a new item, and it will have the item ID of 1, and then the catalog ID of 0, and give it a price of 5. We can also, later on after created, we can query it, just get the table record, and also get the data directly from the logs. Once we have the overall, we could have a table repository. The table repository is where all that data can be stored. In this scenario, as you can see in the screen, we created an in-memory table repository. But obviously, you can have a Postgres, etc. And that way, we can query extract all the data and store it locally or in memory or in a database. And let's have a look how this will look in the database. So Nethereum now also includes the Ethereum mod repositories EF package. For anybody familiar with .NET, the EF is the entity framework, which mainly provides a common provider for many databases, so you can actually store the data there, and a specialized version for Postgres, as we have a different way to store the data, so as Postgres allows to store bytes. And once we start processing this, we get all the data here. And as you can see, this is all the data from the world system. Very similar to what MUD does in the JavaScript version. And you can see that everything is encoded there, and yeah, managers can see all the data. But obviously, because everything is encoded, we want to be able to query the data. So in Ethereum, it also includes a new predicate builder, which will allow us to query the data and then using simple queries like equal, not equal, and or, etc. So this will dynamically create some queries that it will create the database. But obviously, sometimes we want to see the data in the database. So it also includes a new normalizer there, which mainly will convert all the data in tables in the database. The previous versions, it also includes a REST API, just in case, obviously, if you're working on WebGL, you will want to connect to that data. But in here, we just leave it on your own, so because you might want to create different indexes and optimize the database once you have extracted all the data and recreated. So that was the data. So what happens next? Let's look at the system scope. Obviously, we want to integrate with the logic. So first of all, we have our system service. Our system service is the normal Nethereum code-generated service. So in here, we can access the method purchase catalog item. But also, there are extensions for to convert this service into a system service for MUD. In here, we see as you see in the top, we have the catalog as the system name, and also ways to do the deployment and in .NET. Once we got all the tables and the systems, we can add it into our custom namespace. We just create some classes there, and then later on, we connect all this into our player service who will integrate in your game. And in here, we can see which has a simple method which will do the purchase item from catalog and wait for receipt is async. And so mainly, this will go into your LAN namespace, and it will go to systems, go to the catalog, and do the purchase. And also, afterwards, it processes all the changes. That we'll talk about it in a second. So now we got the method. We can connect it and create a simple Blazor or HTML UI. So we can purchase our crazy oven and then put it in our Unity. Obviously, I have not built the Unity UI yet, but the beauty of having two different front ends is like I can test it in the HTML version because building something in Unity takes a lot much longer. So now we go locally. So talking about local state. So as we can see before, we were talking about what happens after safe, and I do a process of the changes. So sometimes, we have seen many demos here that you might want to constantly send transactions for every movement, but in other ways, you can want to keep a local state and keep it in memory and batch or bulk save all the data after many actions. So this will reduce the number of transactions, and then will save your gas. So maintain a local state. What we do is keep it an in-memory table repository. That's the one I was talking before. But in here, what we do is once the user starts the game, we load all the data in the current state, and any actions that we do, we keep it in a separate object. Also, any actions that the user will make, we keep it into a collection of actions that we keep in memory. So later on, we can batch those actions. So first, and obviously validate all the actions that we keep in memory using the logic in .NET. So what happens if I craft something or anything on the LAN? So mainly, I craft something, then the logic, I'm doing the validation internally and keep all the logic in .NET. And later on, I just, once I'm finished and I have done all these actions, I use the magnificent thing called system call multi-input, and then batch all these operations into the node as a one single transaction. Once all this saved, we want to synchronize the data. And instead of like having something in the background running as a processor, we can use the logs of the receipt. So the logs of the receipts will bring all the changes that has happened on the database, sorry, in the blockchain. And then blockchains can come from the chain, so we can keep logic in .NET, but not everything. So we have like things like XP point changes, level progress, etc. So many the core logic that where people will normally cheat in your game, we can keep it. We'll keep it obviously in the EVM. So apart from this, obviously we have deployment and testing. So the way that Nethereum deploys, if you wanted to deploy with Nethereum, Nethereum has also the MUD smart contract. So this is deployed as a using World Factory, etc. Then deploy your tables and then configure the tables and the systems and register as well all the functions as well there. This becomes very helpful because if you want to run your integration testing against your .NET code, you will constantly run in the deployment, configure all the data, etc., and then just run the testing. Ethereum also includes some little tools to provide integration, help-us integration for testing, and also extension for like common development nodes like Hardhat or Anvil. And finally, but not least, one of the coolest things about MUD is got the delegate authority. So the capability to have temporary private keys, etc. So you can not having a link to your main account will have all the money, etc. So this is also supported as well. And this is going to be the basis as well for account abstraction that we're going to put in Ethereum later on. As it's allowed me to think about a better pattern to solve how to put account abstraction there. Wrapping up, so we have seen how we can start with a Blazor Unity front end as well, all integrated with the player service, having our MUD namespace and sister servers and table services within .NET, a local state, all integrated with your Ethereum node, and doing the store close processors to get all the data in the database, do a deployment, and integration testing, all in the .NET world. Yeah, here's some links. So if you need to play around, and yeah, Q&A.
Thank you. All right. So same as before, scan the QR code to ask question to Juan. Because there are no questions yet, I will ask questions. So you kind of rebuilt the whole stack in .NET. Yeah. So what did you find, what was hard about it? What was surprisingly easy? Where were you able to reuse a lot of your work? I'm kind of curious about your journey doing that.
Obviously, the hard part was encoding and decoding because you have packed so much data. So I modified an Ethereum AVI to support the packing and the decoding of the pack data. Just mainly using the fixed areas, but mainly I extended there because actually fitted very well, because we have all the pack functions that Solidity provides, so it actually fitted very well as an extension. On top of that, in Ethereum MUD is where the specifics of MUD are put in place just to do the extra decoding and encoding. So that was one of the hard parts. Overall, I really, really like this, as you may know, because I said 9 years. As an example, 9 years ago, when we were talking about Ujo, I don't know if somebody remembers Ujo, and we're talking about the music, etc. One of the main things, like, hey, what do we do with the data? How we can have some structured data that we can actually put the artists and so on, the records, etc. And we have all these huge debates, how what we're gonna do with this. Fast forward 9 years later, now we can do it because we're scaling. Before that, it's like, hey, let's put this in IPFS, but where's the logic? You know? So love it. It's fantastic. So now we can actually, it's just not just gaming. The gamings are great because obviously can provide some fantastic logic and also application. Yeah.
So you've heard it here first. Juan thinks MUD can be used for anything, not just gaming. It's just the beginning. So we got one question from the audience, which is, how do you prevent data conflict in MUD since you're not saving everything immediately to the chain? Thus, you're saving to the stale game of the state, to the stale game state that there's hundreds of players in the world.
Right. Obviously, that example is for a single player within your confined land. So it's obviously, this is not based on a multiplayer environment. For that, we'll have to think about it. So obviously, you will have to think about how to delimit that part of the data. And so if you don't really want to constantly sync and then say like, hey, this portion is where you are working. and then that way allows you to keep that data without saving all the time. Obviously, the other solution is like constantly syncing, etc. But if you have millions of users, eventually you're gonna get some scalability.
I mean, here it's because each player has a lock on their land essentially, so that's why they can work offline. Okay, makes sense. We have another question here, which is, are you guys going to do this for Godot or Unreal Engine?
Everything that works in Unity works in Godot.
Bullish for Godot, guys. If you use Godot, you can just use all of this.
Yeah. So that was that first slide. So mainly this works using normal tasks, etc. in .NET. So mainly anything that works there, it works in any of the parts of .NET. And hence the example with the Blazor, because here you call it WASM, Blazor app. So that's not running in a web page. It's mainly like fully WASM there. So it will work in Godot. One thing is that Godot, the latest version 4, they are yet not supporting the latest version of .NET, but that's mainly Godot and .NET issues. But yeah. And Unreal, I found the other day that there is a new extension, a plugin for Unreal with Unreal Sharp. If I remember the name, because it's like very, very new. And so, yeah, you should be able to work with Unreal as well.
Do you know if the Unreal.NET integration is from Epic Games, or is it like a third-party thing?
Third party. The Epic Games was supporting another one, but that went stale. But this one, it seems to be working. But again, it's only working on desktop, and that's because obviously when you start thinking about IoT and mobile, etc., it gets a bit more complicated. But obviously, desktop, Mac, and Windows and Linux is all right. Yeah.
Someone says, "Thank you for your VS Code extensions. You rock." Can you guys scroll down a little bit? As a 3D artist, I wonder how are 3D assets integrated in MUD, as some can be very heavy with textures?
Obviously, you will have to ask the Unity specialist on that. But the Unity assets are something completely different. So obviously, that's nothing to do with the mod framework in itself. So if you have something that's very heavy, Unity has ways to deploy things like in WGL that you can do it dynamically. So yeah, you can load dynamically the data. In our game, nothing is done dynamically yet because, the Cafe Cosmos game.
Yeah, probably the assets are not very big.
It's not needed yet. Yeah.
Yeah, and I think for the person asking the questions, with MUD, you don't need to store your assets in MUD. Like assets are just about viewing the state. Only the key state needs to be stored in MUD. I mean, you can do it, but I don't think it's a good idea.
No.
Okay, I think that's it. Thanks again.
Right. Thank you.